Hi everyone, we are going to go through how to solve an empirical formula problem today. You'll remember from your reading that the empirical formula is the formula for a compound that is in the lowest ratio of subscripts possible. So we're going to go through how to do that. I have a sample problem for us to do today, and it is to find the empirical formula of a compound that is 35.98% aluminum and 64.02% sulfur. So we have several steps we're going to go through. First of all, we need to figure out how many moles we have of each element. Now I know that it was given in percents in the problem, but we are just going to pretend that we have a 100 gram sample, which means that we're going to treat these numbers like grams. Okay, so we're going to start with aluminum. Our problem says we have 35.98 grams, and to turn that into moles, I'm going to use my molar mass ratio, and I know, using my periodic table, that 1 mole of aluminum has 26.982 grams of aluminum. Okay, so once we plug that in our calculator, we get 1.33. We're going to do the same thing with sulfur. We start with 64.02 grams, use our molar mass ratio, and from our periodic table, see that there's 32.066 grams per mole of sulfur. I calculate that, and I end up with 2. Okay? So that's step 1. We know how many moles we now have of each element. The next step is to take those numbers and divide them by the lowest. So for aluminum, we had 1.33, and sulfur, we had 2. Looking at those numbers, 1.33 is the smaller, so we're going to, for both, use 1.33, and aluminum will end up with 1, and sulfur, we end up with 1.5. Okay, you will always, obviously have one of them have 1 for an answer, since that's the number that was the smallest. Okay, so that's step 2. The next thing we're going to do is look at those numbers that we just found. Aluminum, we had a 1. Sulfur, we had a 1.5. Okay, I need these to be whole numbers. So you're going to find the lowest factor you can and multiply both of them by that so that we have whole numbers all around. So 1.5, I know that if I multiply it by 2, I end up with 3. So I'm going to do the same thing with aluminum. Okay, now I've got a 2 for aluminum, 3 for sulfur. They're both whole numbers, so I'm done with it. The last step is to take those numbers that we just found. Aluminum was a 2, sulfur was a 3, and we're going to put these in as our subscripts. So our formula is going to be Al2S3. Okay, that is the empirical formula for this compound. We can double check to make sure that our answer is reasonable by looking at the two numbers and making sure that they are in the lowest possible ratio. Okay, if you end up with a 2 and a 4, you know you've done something wrong. But now we have 2 for aluminum and 3 for sulfur. Can't reduce that anymore, so we know we are correct. So there you are. That's empirical formula. Try it out on your practice problems. Remember, for your empirical formula problem card, you're going to pick one of the practice problems from the textbook that's listed right after the example problem and show all your work. Okay, then let me know if you have any questions when you get to class.